Ingrid starts with N chocolates, while Jin and Brian each start with 0. Ingrid gives 1/3 of her chocolates to Jin. Jin gives 8 chocolates to Brian, and then Jin eats half of her remaining chocolates. Jin now has 5 chocolates. What is the value of N? Of Ingrid, Jin, and Brian. So we start off with N, and then 1/3 is transferred to Jin. So now this becomes N over 3, and this is now 2N over 3. And we're still at 0 here for Brian. And then now 8 goes over to Brian, so 8, but that's coming from Jin, so this is now N minus 3 minus 8. And this 2N over 3 has not changed. And then the very last thing is Jin eats half, so this becomes half of what was previous. And I think these two don't change. This is still 8, and this is 2N minus 3, 2N over 3. And then now they're telling you a numerical value, that this thing is equal to 5. So that is the algebra. So let's solve it. So we have 1/2 N over 3 minus 8 is equal to 5. Multiply through by 2, and we get N over 3 minus 8 is 10. N over 3, therefore, is 18. And therefore, if you multiply through by 3, you get 54. For what value of k is k% of 25 equal to 20% of 30? So k% is really k over 100. And they're taking that of 25, and they're saying it's equal to 20%, which is 20 over 100 of 30. So that is the equation. So let's solve it. Let's multiply through by 100, and when we do, we get 25k, and this will be 20 times 30, which I believe is 600, and therefore k would be 600 over 25, and that I think is 4 times 6, which is 24. It is now 1 a.m. What time will it be? 2023 minutes from now. 1 a.m. is where we begin. Now this 2023, it's in minutes, right? So I want to convert it to hours in minutes. So just divide through by 60. And when you do, you get 33 hours and a leftover of 43, which is minutes. Okay. So I just have to add 33 hours and 43 minutes to this. Now, if I just do 24 hours, that will eventually get right back to 1 a.m. again. Now, if I subtract that 24 from this 33, that is what, 9? So 9 hours and 43 minutes is what remains. So we just add that to this. So that would basically be a time of 10:43 a.m. A group of 8 students have lockers that are arranged as shown in 2 rows of 4 lockers, with 1 row directly on top of the other. The students are allowed to paint their lockers either blue or red according to 2 rules. The first rule is that there must be 2 blue lockers and 2 red lockers in each row. The second rule is that lockers in the same column must have different colors. How many ways are there for the students to paint their lockers according to the rules? Let me just draw it on the side here because I'm going to fill it in. So this is basically the 8 lockers, right? And I'm just kind of experimenting. If this is blue, then this has to be red according to the rules. If this is blue, this has to be red. And then the other 2 have to be red because you have to have 2 blue and 2 red in the same rows. And then in the same column, there has to be 1 blue and 1 red. So it's a basic kind of understanding. So that's one such way of doing it. Now, so basically what you're saying is you got a BR, then you've got an RB, and you've got an RB. Yeah. So, and then you have to shuffle these around. So I'm just going to give them letters. So I'm going to call this one M, and I'm going to call this one N. And then I have to figure out how many combinations are there of those 2 M's and 2 N's. Okay, let's see. I don't think this will be that difficult. M, M, N, N, which is what I did. And then I'm just going to keep M as the first one and then shuffle these guys around. So the M could go here, N, N, or the M could go here, N, N. So that exhausts the ones with M as the first. Now let's put N as the first, and that would basically mean M, M, N, or you could have N here, or you could have N there, and that takes care of the ones where N is the first. And I think that's it. Yeah. So that is a grand total of 6. And I guess that's the answer to the question. In trapezoid ABCD, AB is 4, CD is 6, angle DAB is 90, and angle BCD is 45. AB is parallel to CD. What is the length of BD? All right, so let's label this. So that's 4. Let's draw a line that goes straight up and down like this. That's perpendicular. So that would be 4, and that would be 2 since CD is 6. Anything else we can label here? Well, let's talk about the angles then. BCD, this is 45 degrees. Well, if that's the case, then that's 45 in that triangle. Then that means this is the same as that. That makes it isosceles, so that means that top to bottom length is 2. And then I guess we have everything we need to calculate BD with Pythagoras, since this is going to be a right angle. BD squared would be 4 squared plus 2 squared, and that's 16 plus 4, which is 20. So therefore BD would be root 20. And root 20 is what? 4 times 5, so that'd be 2 root 5. A train is traveling from city A to city B. If the train travels at a speed of 80 kilometers per hour, it will arrive 24 minutes late. If it travels at a speed of 90 kilometers per hour, it will arrive 32 minutes early. At what speed should the train travel in order to arrive on time? So we're going from A to B, and the distance I don't know, so I'll just call it D for now. And then, of course, throughout this question, we're going to use that standard formula. Speed is equal to distance over time. Very important formula to remember. Okay, so let's talk about this here. If I rearrange this to be time is equal to, well, there's many variations. Time is equal to distance over speed and so on, and then distance is equal to speed times time, whatever. So we will eventually use one of those, or maybe more than one. Okay, so let's talk about the what they told me in the question, that if the speed is 90, let's see here. Then the time, if speed is equal to 90, then the time is 32 minutes early. So let's say T is the time that the train arrives on time. Okay? So if it's 90, then it would be T plus 32. Or see, sorry, hold on. Early, so it would be minus 32. Minus 32. And I've got to convert that to hours because the speed is in kilometers per hour, so that's why I got to put the 32 over 60. Okay, so let's hopefully get this right the second time. If the speed is 80, then now the time would be, let's see here, it would be 24 minutes late, so it would be T plus 24. It would be 24 over 60, of course, because I got to convert it to hours. Okay. And then distance is equal to speed times time, but the distance is the same for this scenario and this scenario because we're always going from A to B. So the two distances are the same, D1 and D2. So D1 is calculated with speed of 90 and the time of T minus 32 over 60. And then D2 is calculated in this way, where the speed is at, well, it doesn't matter. I actually, this way, I did the other one first, I guess. 90 times 32. So I'll just put this one as 80, and then the time is T plus 24 over 60. Okay, well, same thing, it doesn't matter. Okay, so I guess this will allow me to solve for T. So let's do that. So this will be 90T minus 48, and this will be 80T, and that will be 32, I believe. And then that's going to be 10T is 80, and therefore T is 8. Okay, but they want the speed. So I'm not done here. I've got to calculate speed here. Okay, to calculate speed, where do I go from here? I need to first know the D. Okay, so the distance, I guess I can put it in any one of these guys. This is the distance, and the distances are the same. So 80 times t plus 24 over 60. And then t is 8, so if I plug that in there, it would be 8 plus 24 over 60. And this crunches out to 672. Okay, great. So I've got t, I've got d, and then finally I can calculate s. Because s, as you know, is distance over time. So that's going to be 672 over 8, right? Yeah. And that comes out to 84 kilometers per hour. In triangle ABC, tan of BCA is 1, and tan of BAC is 1 over 7. The perimeter of triangle ABC is 24 plus 18 root 2. The altitude from B to AC has length h and intersects AC at D. What is the value of h? Well, let's label as much as we can here. I'm going to call this guy theta and this angle alpha. And let's see what we get. BCA, therefore, is the theta. So the tan of theta is 1, right? This angle right here, BCA. So that means theta is 45. I can do that in my head. So that angle is 45. And since this is a right angle, that means this is 45 also. So that's 45, and that's 45. Okay, so that means this DC is h, since that's an isosceles triangle now. Okay, that's pretty good progress. And now let's look at the other guy, this one. Tan of BAC. So BAC I've called alpha, and that's 1 over 7. So tan by definition is what? Opposite over adjacent. So opposite over adjacent, and adjacent is what? AD, yeah. So that means 7h is AD. Okay, so let's put 7h there. Now what are we trying to figure out here? The value of h, and then the perimeter, the perimeter of the whole triangle. Okay, so that means I've got to figure out AB and BC. Okay, so I should be able to figure that out with Pythagoras pretty easily. AB squared would be 7h squared plus h squared. So that looks to me like 49 plus 1, 50h squared. So that means AB is root 50h. And root 50 is what? 25 times 2, so 5 root 2. So 5 root 2h. Okay, BC squared, that is going to be BD squared plus, where is it? DC squared. So that's, just h squared plus h squared. So that's 2h squared. So that means BC is root 2h. So therefore now the full perimeter, if I were to write the full perimeter, that is going to be, P for perimeter is AB plus BC plus AC, correct? So AB is 5 root 2h, BC is root 2h, and then AC, all the way from A to C, is 8h. Now let me see if I did that correctly. Yeah, I think I did. Okay, and they've told me that it's equal to this guy here. 24 plus 18 root 2. Okay, so that's what's going to allow me to solve for h. All right, so let's see here. So this, if you combine it, will be 6 root 2h plus 8h. And I guess I can factor out an h. It'll be 6 root 2 plus 8. And this side here looks very similar to this. If I factor out a 3, I think I'll get that. Yeah, I'll get 6 root 2 plus 8. There you go. So the 6 root 2 plus 8 cancel, and we get h equal to 3. A Tim number is a 5-digit positive integer with the property that it is a multiple of 15, its hundreds digit is 3, and its 10 digit is equal to the sum of the first leftmost 3 digits. How many Tim numbers are there? 5 digits. And let's see here what kind of information they give me. The hundreds digit is 3, okay. It's a 5 digit, okay, I already did that. A multiple of 15. So if it's a multiple of 15, like 15, 30, 45, 60, 75, 90, and so on, well, these aren't even close to being 5-digit, but one thing is for sure, that the last digit will be either a 5 or a 0. Any other tens digit, which is this guy, is equal to the sum of the first 3 digits. So well, let's just call this A, let's just call this B. So this would be A plus B plus 3, this guy here. Okay, I think that's it. That's all we have to work with. Not much. Okay, so let me first think about this for a second. How many choices do I have? For A, I have every digit from 0 to 9, right? But I can't put 0, because if I put 0, it would no longer be a 5-digit number. So everything from 1 to 9. So I have 9 possibilities. I'm just looking at the total. And then, of course, we have to narrow it down because we've got some criteria here that have to be met. For B, I can put everything from 0 to 9, so that's 10 choices. This third number is just going to be 3, so there's only one choice here. A plus B plus 3. A plus B plus 3. Let me think about that for a second. What would be, how many choices would be for that? I don't know. Well, let me think about that for a second and come back to it. The last one, of course, there's only 2 choices. A plus B plus 3 is not as obvious. So I think I'm going to have to make a table here. Yeah. And then I'm going to also have to take into consideration that the whole thing has to be a multiple of 15. Yeah. And if it's a multiple of 15, it's also a multiple of 5 and a multiple of 3. And with the divisibility rules, if something is a multiple of 3, the sum of the digits is a multiple of 3. So sum of digits is a multiple of 3. So a lot of criteria here, but I think it should be okay. So let's see here. We've got A, B, then we have that A plus B plus 3, and then we have the sum of the digits. So sum of digits. Yeah. Sum of digits of just these guys, these 3. Because the 3 is not going to change anything. Well, because if it will, 3 is already a multiple of 3. So, and then this last one, the 5 or the 0, that we will have to discuss later. But let me just make this table first and then kind of proceed from there. Okay, so let's see what we get. All right, so I think I'm going to need, hopefully it doesn't go too long, but let's just see here. All right, so let's start off. Remember, we can only go from 1 to 9, and this goes from 0 to 9, so that's why I'm putting 1. For 1, B, the smallest is 0. This would therefore be 4, and the sum of the digits is 5 for just those 3. And then so on, like this. We just kind of continue. I'm just doing A equals 1 for now. And then we will stop once we reach 9 because that's the highest a digit can be. So that's where we kind of stop. We can't go any further because this has to be a digit between 0 and 9. Okay, so the sum of the digits, let's add those up. 7, 9, this is what, 11, 13, and 15, right? Okay, so we have to just do this full list for everything. So let me just fill those out really quickly, and then I'll come back. So that's the full table, but not all of these will qualify because we still have to try to match that rule. Okay, so if the last digit is 0, then the sum of the digits would be this. The total sum of digits of all 5 will be that plus the 3. Remember there was a 3 here, and then that 0. So the sum of the digits, therefore, can be a multiple of 3 if this number in this column is already a multiple of 3. So for example, this guy is already a multiple of 3, right? So if we add to it that 3 and that 0, this 3. So to repeat, this number here, if it's already a multiple of 3, when we add to it this 3 and this 0, it will still be a multiple of 3, as I put here. So let's circle those ones, the ones that are already a multiple of 3. So I already circled the 9, I believe the 15, that's already a multiple of 3. Let's see here, this 9, this 15, this 6, this 12, this 12, this 12, and this 12. So how many are that? 1, 2, 3, 4, 5, 6, 7, 8, 9. So those 9. Now let's talk about other numbers. Another number in this column would be able to satisfy that rule if we use this 5, because we haven't talked about the 5 yet. So this 3, this 5, and then the sum of the digits in that column. So for example, 7, this 7 here, let me use a different color here, let's use green. That's 7 plus the 3 and plus the 5. That would be a multiple of 12, I believe. A multiple of 3. So that would be what? 15. And 15 is indeed a multiple of 3. So let's circle numbers that when you add 3 and 5 would become a multiple of 3. And that would be this 13 would do it, right? Because you're essentially adding 8. And that would be 21. This 7 would do it, I believe. And then this 13. This 10. This 10 here. And this 10. Yeah, so that's 1, 2, 3, 4, 5, 6, 7. Okay, so we got it. So then we just have to make the numbers now. What are they asking here? How many? They're just asking how many. So the total would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 is the answer. But let's just list them. I don't think it'll take that long to list them. So for example, if I'm using just the ones that I've circled, it would be, I'm going to put them in two columns. I'm going to put the zeros, which is the ones I circled in red. There's 9 of those guys. And then the 5s, I think there's 7 of those guys. And that is the full list, and I don't think the list was required, but just for the sake of completion, and it's a total of 16 Tim numbers. The real numbers x, y, and z satisfy both of the equations below. Given that x plus y plus z is p over q, what is the value of p minus q? Let's call this equation 1, and let's call this equation 2. So let's see here. If I take 2 times equation 1 and add to it 3 times equation 2, I will get the following. I will get 8x plus 14y plus 2z plus 9x plus 3y plus 15z is equal to 22 plus 45. And when you collect like terms, you actually get 17x plus 17y plus 17z equal to 67. So that means if I factor out a 17, I get x plus y plus z is equal to 67, and therefore x plus y plus z is 67 over 17. Now x plus y plus z, they're saying is p over q, where p and q are both prime numbers. Is that right? No, not necessarily. It's just, oh no, just p over q is in lowest terms. Now is this in lowest terms? I believe it is. Yeah. So therefore that p is 67 and that q is 17. So therefore this p minus q would be 67 minus 17, and that is 50. For every positive integer n, let Sn equal 1, 2, 3 all the way up till n. That is, Sn is the set of integers from 1 to n inclusive? There are 2n subsets of Sn. If each subset has the same likelihood of being chosen, let Pn be the probability that a chosen subset does not contain two integers with the sum n plus 1. For example, the subsets of S2 are the empty set 1, 2, and 1, 2. Of these four subsets, only 1, 2 contains a pair of integers with the sum of 2 plus 1, which is 3. The other three subsets do not contain such a pair, so P2 is 3 over 4. What is the smallest even positive integer, n, for which Pn is less than a quarter? All right, so let's talk about this. Let's explain it first. And they've given you a very good example, so that's very nice of them, and illustrating this part. Let me do one more example. So hopefully by the time you see my example, you'll be able to fully understand the question, because it might be a little abstract. Let's say they've given me for S2, so I'll do S3. So at this point, I've set n equals 3. So that means S3 is really just 1, 2, and 3. That's my initial S3. Now we have to figure out the subsets. And they are very nice here. They actually told you that there's going to be 2n subsets. That is actually very helpful, because if you look at the probability, it's always a fraction, right? And this is the total, and this is the specific condition. You guys have done probability questions before. Specific condition. Well, the specific condition is what they've described, and now we'll of course have to calculate that. But the total they've already given you, 2n. The total is this guy right here. That's very, very helpful. I'm surprised they even did that, because they've pretty much given you the denominator of the probability. That's nice of them. Okay, so here we go. But I'm going to list the subsets. Now, before I even list them, I know it's 2 to the n. So the number of subsets would be 2 to the power of 3, which is 8. So I'm going to have to come up with 8 subsets. And I think I can. So the subsets, so first you have the empty subset. Then you have the 1, the 2, and the 3. Then you have 1 and 2, 1 and 3, and 2 and 3. And then you have all 3. So let me see. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I got 8 subsets. Okay, now what I have to do is figure out the condition, which is a very specific condition here. Pn is the probability that a chosen subset does not contain two integers with the sum of n plus 1. Okay, so let's see how many of these guys have that criteria that they have, let's say, two integers that add up to n plus 1. So n in this case was 3, so n plus 1 would be 4. How do we get 4? Well, 1 and 3 could add up to 4, so this guy, this 1 and 3 could add up to 4, and I think that's it, right? Let me see. Yeah, so the Pn in this case, which would be P3, is the probability that a chosen subset does not contain two integers. So those two do, so the other 6, 1, 2, 3, 4, 5, 6, those guys do not contain two integers with a sum of n plus 1, which in this case was 4, since n was 3. So the probability here is 6 over the total, which is 8, which is 3 over 4. Got it? Yeah. I think that's right. Yeah. 3 over 4. So that is really how you'd approach this. Now, I encourage you, if you still don't understand the question, I encourage you to do the same thing for S4, where n equals 4, and the subset would be 1, 2, 3, 4. What is that squiggly line? I've got to do that. Actually, you know what? I'll do it. I think that if you understand the question, it would make it much easier. So let me just do it. We won't take that much time. Again, the very helpful hint that the number of subsets is 2 to the power of n, so that would be 2 to the power of 4, so 16 subsets. So the subsets, since there's only 16, it won't be that difficult to list them. We've got the empty subset. We've got 1, 2, 3, and 4. We've got 1 and 2, 1 and 3, 1 and 4. 2 and 3, 2 and 4, and finally 3 and 4. Okay, and then we've got to add 3 of them. So 1, 2, 3, 2, 3, 4, 1, 3, 4, and 1, 2, 4. And then finally all 4 of them, 1, 2, 3, and 4. So let me see, is that 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes, 16. Great. And now I've got to figure out the criteria, which is that the chosen subset does not contain 2 integers with a sum of n plus 1. So first let's talk about how many do contain 2 integers that have a sum of n plus 1. N is 4 in this case, so n plus 1 will be 5. Alright, so which ones contain 2 integers that have a sum of 5? This guy does. 1 and 4, that does. Anything else? I don't think so. These 2, that would add up to 5. These 2, 1 and 4, these guys, 1 and 4 again, and then 2 and 3. Okay, so how many do not? Because the key is do not. So do not would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So probability of 4 would be 9 over the total, which is 16. Okay. Okay, so hopefully by now you understand the question. Now, this is not required. I just did that to explain the question. I really wanted you to understand it, because otherwise, if I start with the solution, I don't think a lot of people would understand the solution if you don't understand the question. Okay, so now let's proceed with the actual solution. Now, one thing I just noticed here is that this 3 over 9 is actually 3 over 4 squared, right? 9 over 16. Now, I don't know if that's an actual coincidence or if that actually means something. I think it does, but let's just proceed with the solution. Okay, so now we got to go with the solution. So we're looking for Pn, right? And Pn is going to be our specific condition over 2 to the power of n. So it's very helpful that they gave us that 2 to the power of n. So this specific condition is what we're going to concentrate on in the solution to the question. Okay, so they also told me, very, very helpful, that they actually just looking for even values of n. Okay, if n is even, then we can just let it be equal to, say, 2k, because any number of the form 2k is even. So this really just becomes P 2k is equal to something over 2 to the power of 2k. Correct? Okay. And then therefore Sn, which is S2k, we have to then choose 2 elements from the subsets. We have to choose 2 elements. Is the word elements correct, or is it integers? Let me see it here. 2 integers. There's not 2 integers. I don't know why I chose elements, but 2 integers, elements, whatever, same thing. That add up to n plus 1. So in this case, that would be 2k plus 1. Okay, so we have certain variations. We could have, the subsets could be like 1 and 2k. That adds up to 2k plus 1. Or 2 and 2k minus 1. That adds up to 2k plus 1. 3 and 2k minus 2. And so on, right? And so on. So all the way dot 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 until you get to k and k plus 1. So that would be the full sort of possibilities. And this is obviously, if you're going from 1 all the way down to k, there's k such subsets. Correct? Okay. Now for each of these, we have to talk about subsets that do not have this. So not have this subsets, because that is essentially what they want in the question, right? This word not is really what they want. So I just put it into two categories. First, I talked about the ones that do have it, which are these guys, and then I'm talking about now the ones that do not have it. Now, do not have it, if we look at, say, the first one, 1 and 2k, that would be a subset that does not have, so let me write that down, does not have both 1 and 2k, or does not have the 1, or does not have a 2k. So that would be three such subsets. Now let me give an example, right? That's a bit abstract. Let's say our numbers were 2 and 3. That over here. So over here we have a subset that had 2 and 3. And that is 2 plus 3 equals 5. So that would be the scenario when n was 4. Then n plus 1 would be 5, remember. Now we don't want that. We want this kind of scenario. So therefore, we would want subsets that do not have the 2 and 3, or do not have a 2, or do not have a 3. Because if they have both, they're going to be placed in this category. But if they don't have either one or both, they'd be put into this category. And therefore, that's 3. So for every one of these guys, you're going to have every one of these subsets, you're going to have 3 subsets that don't have those elements. So 3 for this one, 3 for this one, 3 for this one, and 3 for this one. So all of them basically will have 3. So since there's k, you're going to have 3, 3, 3 all the way down that, and this is the category that does not have the subset. So does not have 2 integers that add up to n plus 1. So that basically is 3 to the power of k. And that is our numerator. That's our numerator right here, 3 to the power of k. So a big long song and dance to explain the numerator. Okay, so I think I'll just keep it in the same screen. So therefore p to the 2k is really, I think I can put this under 3 over 2 to the 2 all to the k, right? And therefore that's 3 over 4 to the k. Okay, that's very helpful. And I was right. See how this was 3 over 4 to the 2? I knew there was some correlation there. And this is obviously 3 to the 4 to the power of 1. Okay, now finally they want this criteria, that they want it to be less than a quarter. Okay, so let's do that. Let's make this less than a quarter. And if I make it less than a quarter, then 3 over 4 to the power of k is less than a quarter. And I guess we have to figure that out. Let's see here. A quarter is 0.25, right? Okay, so 3 over 4, which is actually, let me convert it to decimals. So what power of k will it be less than 2.5? Oh, if k is 1, then this guy will be 0.75. If k is 2, it becomes 0.56. If k is 3, it becomes, I'm not sure, but we actually only care about even values. So let me jump to 4. That'd be 0.3, I think, 0.31. K is 6. It becomes 0.42, I think. Oh, wait, hold on. I'm confusing k with n. Sorry, this should have been 3, and this should have been 4, because n is 2k. I forgot about that. N is 2k. Okay, so that is 0.31. When k is 4, then n is 8. So that's 0.42. When k is 4, it's 0.31. And when k is 5, I think this is the one that does it. 0.23. So this is less than 0.25. So that happens when k is 5, and if k is 5, since n is equal to 2k, n is equal to 10. And I think that's what they wanted, right? They wanted, yeah, what is the smallest even positive integer n for which Pn is less than a quarter? And therefore, the answer is n equals 10.